Right, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aisyah Amira binti Mat Isa and my record number is CF200029. So here our slide presentation for the project MFA 10203 Advanced Structural Analysis. The next slide is the table of contents. Here is the contents that we will talk about, which is the first one is executive summary, introduction, project briefing, design parameter, part 1 modeling that include theory and software, part 2 analysis, manual and software, and the last one is the conclusion. Alright, so firstly is executive summary. Our project we involve by utilize StatPro software to conduct structural analysis simulations on a specific 2D Miles frame. So they have two. Based on this project, we use column and roof members. According to the British standard, we use for the column is a UC 254 times 254 times 733. And for the roof members, we use UB 203 times 133 times 25. So the outcome that we get from this project is analysis output presenting axial force, shear force, and bending moment diagrams along with a deformed shape plot visualizing the displacement induced by the applied stress. So next, here is our company profile. That name Azra Consult with a slogan Innovate, Build and Inspire. So basically Azra Consult is a dynamic engineering consultancy company dedicated to the delivering innovative solutions that redefine the landscape of construction and engineering projects. Established with a commitment to excellence, we pride ourselves on being at the forefront of innovation, fostering sustainable practices and inspiring breakthroughs in the industry. Okay, so right here is my team members. The first one is me, Nur Aisyah Amira binti Mat Isa, as a senior consultant manager. The second one is the Rohadatul Aisyah binti Malay as a quantity surveyor. The third one is Muhammad Alif Aimran bin Jamari as a civil and structure engineer. And the last one is Zafri bin Ayub as a infrastructure engineer. Okay, next, they have two project output, which is the first one is analysis of deformed shape plot showing displacements caused by the imposed loading. And the second one is analysis of an axial force diagram, shear force diagram, and the bending moment diagram.
Hi, Assalamualaikum. My name is Zafri bin Ayub. My metric card number is CF20071. And I want to present about the project briefing. For the project briefing, the primary objective of conducting frame analysis in this project is to facilitate the construction proposal for a luxury car warehouse. This warehouse is located in Tanjung Lebong, Langkawi. Okay, this is our proposed location at Tanjung Lebong, Langkawi. For this project, software utilization is StatPro. StatPro is a popular software for structure analysis and design, created by Bentley System. This tool is comprehensive and all-encompassing solution that enable engineer to analyze, develop diverse structure such as bridge, tower, and other structure projects. So for the procedure analyze frame using StatPro, first you have to create a new project. Next, input geometry, measure properties, support conditions, input loadings, analysis settings, run analysis, viewing results, designs, and lastly, generate report in post-processing. Design for parameter for this project. The design would life if using 50 years. For the exposure condition is using XC3, which is moderate humidity concrete inside building with moderate or high air humidity external concrete sheltered from rain. The rest is the fire resistant, yield strength, ultimate strength, and modulus of elasticity. For the actions. Okay, this is the dead load, which is sulfate of roof construction, zinc roofing, service, sulfate of Berlin, and steelworks. For the life load, variable actions, the imposed load is 0.75 kilonewton per meter square. For the wind load, we are using 2.124 kilonewton.
Alright, in this project, we need to model the frame structure in order to analyze it. So the loading calculation is required. First, we go to the loading on truss and frame, which have the loading of dead load and live load. On truss, the total dead load that have in each purlins is 13.5 kN, and the total live load in each purlin is 2.6 kN. Then, all the loading on trusses will be distributed to frame, which give value combination loading in UDL is 11.6 kN per meter. Next, we move to the loading calculation for wind load. For wind, we use the formula of P equals to 0.613 VD square C fixed in, which will consider the windward and leeward. So the loading that we get for wind is 2.124 kN.
Assalamualaikum and good evening. My name is Muhammad Ali Imran. So I will continue to present for the part 1 modeling of the software. So basically for this particular project, we need to design a simple 2D frames that capable to analyze displacement that caused by the imposed loading. Uh, Also can produce Asia force diagram, shear force diagram, and bending moment diagram. So for our group project, we use a Step Pro as a medium to do the analysis of the simple 2D frames. So first of all, what we need to do is we open the Step Pro. So this is the interface of the Step Pro. So if you want to create a new design, we just click over here new. But in this video, I already do this design before this of the simple 2D frame. So I just click at my work before this. So here, just go. So this is the simple 2D frames of our group project. So we go to the front views of this truss. So the dimension of this truss is according to the question. So we can see here for the column is 3 meter and overall span is 8 meter. So the height of the center members is 1 meter. So overall height is 4 meters. So this dimension is uh, given in the questions. So for the properties, we use size for the column, universal column 254 multiplied by 254 multiplied by 73. So this section is from British sections. So for the roof members, we use a universal beam of 203 multiplied by 133 multiplied by 225. So for the materials, we use milk steel, which is the S 275. So we can see here, here is the properties of the table. So once we select the size, we go to the material and we click the steel 275 and we add. So once it's pop up over here, we just drag to the beams that we want to use. So for the supports, according to the question, we need to use the fit supports. So go here, create, and this is for the fit supports. So add, and then it will pop up over here and drag the support to the columns. So for the loading, so the loading that we determine is based on the manual calculation. So this loading is based on the Eurocode standards, Eurocode 1, action on structures. So we get the dead load at the center is 13.5, and the age of the frame is divided by 2. So 13.5 divided by 2, we get a 6.75. So this is for dead loads, and for the live load, we get 2.6 at the middle, and the age of the frames, so divided by 2, so we get 1.3. So for the sway load, for the wing load, we get the 2.124. This value is based on the calculation, manual calculation uh, of the design. So this is the combination for these designations. So first we have a max combination and we have a minimum combination. So once we already select all the materials and select the supports and determine the loading, so we go to the analysis. So here we can check, we can print what we want to see. So here I would like to see the joint replacement, member force, support reaction, and member stress. So once this already determined, we just run the analysis. Okay, so we go to the view output 5. So we check either there is a members fail or not. So in my case, there is no members that fail over here. So this design is acceptable. So that's all for the modeling part. Okay, I will continue to present for the part 2, which is the analysis for the software part. So from the part 1 modeling, we just run the analysis just now. So for the part 2, after we run the analysis, we go to the post processing part. So if we want to go post processing part, we need to run the analysis. Otherwise, you cannot enter for the post processing interface. So after we run the analysis, we uh, found out that there is no fail occur. So we go to the post processing. So for in this platform, we can see the displacement of the frames, the axial force diagram, shear force diagram, and bending moment diagram. So first of all, we go to the displacement. So according to the questions, we need to see the displacement caused by the imposed loading. So we go over here. So there is the primary combination envelope and all. So at all, so this is the load that we consider. So this is the designations, which is a max combination and means combinations. So we go to the live load, which is the imposed loading. So we can see the green line over here is the displacement that made. So if you want to see the value, you just go to the annotate beam results and go to displacement and annotate. So there is the value of the displacement of the frames. So we go structure diagram to close the labels of the size. So here we can see clearly of displacement caused by the imposed loading. So due to the smallest value of the displacement, so there is no movement made. However, we can scale the drawing, this frame, so we can see that this is the displacement, the behavior of displacement if we scale out. So that is for the displacement part, and we can see over here there is for node 1, we consider the live load, the imposed loading. So for the node 1, which is 0 for the resultants, and for the node 2, 0.216 over here, and for the node 3 is 0.448 over here. So this is all the data that show over here. So we move to the axial force diagram, which is we go to the beam results. So this is the beam results interface. So we just get the bigger pictures. So this is if you want to see the Azure force diagram, so we go to the uh, overlay function, which is the Azure force in X axis. So this is the behavior of the Azure force, which is we go to the combination of a max combinations. Okay, so this is the behavior of the combination match combinations. So we can see that from the data, the match combination over here 45.755, and for the beam 2 is negative 54.042. So if you want to see the beam node, the beam reference over here, we just click structure diagram, go to the labels, and we see select the beam numbers and apply. So here we can see the beam numbers, and we go to the force back. So if you want to see the value, we just go to the annotate beam results, edges, and annotate. So there's the value of the Azure force diagram. So the red color is the positive values, and while the negative color is and the blue color is negative values. So here all the data, and we can see that the max Azure force for the combination maximum combination, so 54.042. So the max for the FX combination is 76.991. For the minimum FX for the max combinations, it's negative 63.482. So that is basically for the beam, the Azure force diagram. So we move to the shear force diagram. So here we have shear force in the y-axis and shear force in the z-axis. However, for the z-axis, uh, there is no shear force made. So we can see from the data here, there is zero for the every members. So we only have the shear force at the y-axis. So this is the shear force for y-axis. So if you want to see the value, we just annotate. So it goes to the midpoint only. Okay. So this is the value for the shear force. So we can see here the shear force uh, y-axis for the combination. So for the beam 2, beam 1, negative 8.755, and following by all the beam members. So we see that max for the FY for the combination is 46.485, and minimum is as 12.743. Sorry, max is as 12.153, and for the minimum is negative 9.440. So this is the behavior of the shear force diagram. So we move to the bending moment diagram. So this is the bending moment for the about a z-axis. So we can see here the value over here is the midpoint values. So from the data, we can see that the maximum bending moment for the max combination is 18.563, and for the minimum bending moment for the maximum combination is negative 21.45485. So this data is already recorded through these tables. So we can see the maximum bending moment. It record all the data for all combination load case. So I think there is a little bit about the analysis from the step pro software, which is we have already talked about the displacement, uh, the axial force, shear force, and bending moment diagram. So I think that's all for the software part 2, which is the analysis. Thank you.
All right, we move to the manual analysis. As you can see here in this slide, after the calculation of loading, all the loading will be put in the frame for the analysis. So the loading of UDL and wind load is put there. And then in this analysis, we will analyze two type of analysis, which is shear force and bending moment. First, for the shear force, we will calculate the value of reaction, which give the value of horizontal reaction and vertical reaction. For horizontal, RD we got the value of 44.51 kN and RCY is 43.97 kN. For the vertical, we got value of 2.124 kN. After finish with the reaction calculation, we will um, continue with the shear force calculation. As you can see here in this slide shows the shear force diagram, which include the calculation of shear force. So here we can see that the member of AC, we got the shear force value is 2.124 kN and the horizontal member of AB, we got the maximum value of shear force is 44.51 kN. Then for the bonding moment, we will use and consider the method of plastic analysis. So we will calculate the three type of cases, which is first the beam mechanism, which give value of MP is 44.24 kNm. Then second is sway mechanism, which give value of MP is 1.59 kNm. And also the last one is the case of combined mechanism, which we got the value of 30.5956 kNm. Alright, now we move to the discussion. On this discussion, I will compare the result of the manual calculation and the software calculation. So first, as you can see here in this slide, for the reaction, the software analysis for member 1 and 8 shows the greater value than manual calculations. This is maybe due to the application of loading is different in both analysis where the manual calculation is using combination action is 1.35 GK plus 1.5 QK, while the software have its own setting different. However, the value of reaction is almost close for both analysis, so we can assume that the analysis of both analysis got almost the same value. Alright, for the shear force, the value in software analysis is greater than manual calculation. This is due to the software analysis consider the safety of structure, thus give the greater value of shear force. The greater value of shear force later will affect the choose of structure size. So on the member 8, the value for manual calculation is 0 as no consideration of vertical loading on this member, thus the result gives the 0 answer. And the last but not least, the value of bending moment shows the manual calculation in member 2 is greater than the software analysis. This is due to the in manual calculation we use and consider the plastic analysis method, thus give the greater value of moment on member 2. Now we come to the conclusion. The successful analysis of the 2D frame for the luxury car warehouse achieved through a combination of state pro software and manual calculation. This combined approach not only ensure accuracy in the analysis, but also foster a reliable structural design for the luxury car warehouse. The successful outcome of this analysis highlight the importance of the balanced and integrated approach in structural engineering. Ultimately, this methodology contributes to the overall success and reliability of the luxury car warehouse construction project. Then lastly, it can be concluded that the analysis of this frame using a StatPro software and manual analysis is is efficient approach in this project.